All right, so I spoke earlier about kind of the complexity, and if we go back to this diagram, I mean, this immediately thinking about it, if I had to get my hands dirty, like deploy all these individual pieces, that really looks like this. And again, I'm kind of picking on Dan a little bit. When I spoke to him, when they originally deployed OpenStack, they basically had to do all this manually, all these different components, deploy all these pieces manually. And companies, and so at Branches, we work with all different types of companies. So some companies have been running OpenStack on their own. The first releases is very difficult, and then eventually, like anything else within IT, you automate as much as you can. And so they've gone through and they've automated a bunch of their own infrastructure. But these different pieces, if you look at these different services, these different API tiers, these different databases, there's just a lot going on here that you need to set up to start with. So what we're going to do is we're going to walk through some of these different components, and we're actually going to walk through what provisioning actually looks like within OpenStack. Within OpenStack, all these different components, they're talking to each other via internal APIs. So these internal APIs, these RESTful APIs, basically get aggregated into one common API that the user is using to provision different pieces. So for example, I mentioned heat earlier. So if I'm using heat and I'm saying I want to instantiate my application or my environment, heat is actually going to be touching all these different APIs, but I'm actually using one single API through heat that I'd be using to provision. So Keystone, we mentioned Keystone already, and we'll dive into these components, but within Keystone, this is your authentication framework, but if I had to sit there and actually issue the commands myself over HTTP, so if I'm issuing like REST or curl statements or whatever I'm doing, that'd be really difficult. So all these pieces automatically handle all that for you, but each project has their own API that is automatically built in that you don't have to worry about configuring. Now, from a message queue perspective, if you look at the overall architecture with each project, it all looks very similar, right? So you have your different queues, you have your schedulers, and then the other thing here, which I don't see, so there's Conductor. So what Conductor is it's actually this, within Nova itself, what Conductor is, and we'll dig into it a little bit, but it's almost the security mechanism that it prevents somebody from accessing some of these APIs directly. And we'll kind of talk to that. And then lastly, how do we track state? So again, if I'm deploying all these different projects, if I'm doing Nova or I'm doing Cinder, different pieces, I basically have to have a database stood up. I have to manage that database. I have to orchestrate that database. There's a lot going on here, and yes, you can build it out on your own. You should automate it, but there are distributions out there that can handle this for you. And again, the value is using those distributions is that they should be able to provide you that end user enterprise support. Now, the other piece is that what about third-party plugins? So I mentioned, with Cinder as an example, Cinder is the block project, so I can use my NetApp devices, I can use my EMC devices, I can use just my local LVM disks, I can use Ceph. So basically, you can have different plugins that will plug into these different projects and connect in. All right. So we kind of talked about OpenStack and building the infrastructure as a service. I mentioned that these releases are every 6 months. I mentioned OpenStack is that umbrella or that middleware that sits over all these different components that gives you that one common API. And then most of these different components, most of these different projects, you have their own dedicated database. And then obviously some of these will talk to third-party APIs, so whether it's networking gear, whether it's a database, whether it's storage, it all happens. And actually, I can tell you I was actually at a customer site last week, and HP has just come out with this new array, and they actually contributed a driver, and we were able to get it all connected up with OpenStack provisioning runs automatically, which is really cool because in my past, at Sun, we would have to script everything out, and the community has already written drivers that it's just there and it just works. So it's very interesting. All right, so OpenStack 101, this is where we're kind of dig in a little bit. We're going to go through the different pieces of what does provisioning look like. When we think about provisioning VMs, we're like, I just click the button and just say go, or I type a quick CLI command, hit go. But what actually happens behind the scenes? And the interesting thing is that you will touch almost all the components within those previous diagrams. So now when you're the administrator, the end user, I see DevOps up there, but I went to a DevOps conference and they don't want to be called DevOps guys. So you have a person that's going to be provisioning. So Horizon, we didn't talk to this really at all, but Horizon is the default dashboard within OpenStack. And this just gives you a nice UI that you can initially log in and see your OpenStack environment. You don't have to use Horizon, you can build your own portal, and I actually recommend to my customers that, hey, build your own portal so you're providing more value to your guys to do that. But through Horizon, that's where you can actually kick off your provision, or you can use the CLI, or you can use a REST API to initiate the first provisioning. So the user's going to log in, he's going to log into Horizon, and he's going to say, all right, I want to provision this VM, I'm going to give it this name, and the flavor. So the flavor is going to actually be the size and the actual hardware specifications of that VM. It's going to be 1 gig of RAM, it's going to be a 10 gig hard drive, it's going to be this many cores. That's going to be your flavor. If you think about it with like Amazon, for example, this could be your M1 in large or your tiny instances. So these are your different flavors. And then from your keys, this is where you're going to actually be setting your SSH keys that will allow you to automatically log in. Then obviously you hit create. What happens? All right, so now I hit create. The first thing that's going to happen is, well, in order to create, I need to talk to Keystone to make sure that I have the proper access to do that. So now I talk to Keystone, I get that information. Keystone's going to say, all right, here's your token back. Yep, let's keep moving. Now within Horizon, I have that token, that string that's been passed to me, and I'm going to pass it over to Nova saying, yep, he's authenticated. Now we want to continue moving down the path of actually provisioning. So this is interesting. So now let's say, and for the service provider guys here in the audience, this is one area that could be a potential bottleneck, is passing around these tokens. So if I'm constantly checking for these tokens, I could potentially have a bottleneck here. And this is one area that the community is looking at, at scale. Maybe there's a better way to be more efficient. We've heard of some customers having issues with this, but
are they thinking about
caching or something. But so today within the community, there's just one area that maybe we can make better. But I just wanted to call that out. So with
I agree, it's an issue we've already made.
You did? How big was your environment?
A few hundred.
Okay. So yeah, so when you get to larger environments, this is an area, again, this isn't a Mirantis thing or a Red Hat thing. This is a community problem, and I don't know if you guys have voiced your concerns anywhere on Blueprints. You have, okay. Do you guys have your own developers? Have you guys contributed any blueprints saying, hey, this is, have you did?
Well, not for Keystone.
Okay. Okay. So it is an area of concern. There's lots of different pieces here, but this is something we should look at. I'm glad someone was here and will verify that there is a problem. All right, so the API characteristics. So again, we're making these REST API calls via HTTP. This is very similar to what Amazon or what Rackspace is going to do. One thing in the community, and people have differing opinions, is that do we want to make our APIs EC2 compatible? And Eucalyptus, one of the reasons why HP said that they bought them was because they did have that API commonality to Amazon. But now what's happening is that there's so many OpenStack developers is that having that EC2 consistency, I think that requirement is probably going to get less and less and less. So it's already been deprecated. So with the compute API, obviously this is where the instantiation is going to happen. And let's keep moving. Okay, so now we're validating that token. If you have over 200 nodes, based on his experience, maybe things are slow. With the actual database, so this is going to be MySQL or Postgres. But at the end of the day, if you're going to be building out OpenStack on your own, pick a database that's going to work for you, and then you're going to have to connect it up into the infrastructure. And then the API, so the API is just how it talks. And then from a HA perspective, OpenStack out of the box provides no HA. I'll say that. OpenStack out of the box provides no HA. And one of our competitors, they actually produced a document that I want to say was like 190 pages or something of how to enable HA within OpenStack. So again, from a value perspective, if you're going to go build it on your own, you get no HA, you have to configure it yourself, or find a distribution that will configure it automatically for you. And I think a lot of distributions are going to get there, but that's just something to think about. But even from a database perspective, like, hey, my database is on HA, if I lose a component, then I'm kind of...
I'm sorry, HA.
High availability. Yeah. Okay. So the next thing is we're going to say, we're going to talk to the scheduler, we're going to put a thing in the queue saying, hey, I actually want a provision. And now scheduler says, oh, I see you actually want a provision. So the scheduler itself, this is interesting. So if you guys come from a VMware background, scheduler is actually one of the pieces that I'm most interested in because of my service provider background. But how do you decide where you actually want to provision? So this isn't like DRS where VMware DRS is constantly like looking at resources and trying to make decisions. This is only when you initially do your provision. So if you want to have rules, let's see, it's the next slide. It might be 2 slides up. But if you want to have rules, like you have different customers that say, you know what, I don't want my resources to be on the same box as this other guy. This is a typical Coke and Pepsi analogy where Coke and Pepsi don't want to be located on the same hardware. I want to have a rule that makes sure that doesn't happen. So scheduler will actually do that. All right. So now what's going to happen is the provision's going to go to the scheduler. It's going to say, are there any rules that I need to be aware of? It's going to check that. Now, this is where the actual filtering happens. So we have these different filters. We can say it's going to be on this node or this node. But some of these examples, this is where my VMs, I want to have them on. I want to group all the VMs on the same host or on the different host. And some of these where I can see being valuable, I'm actually not current on how VMware, or not VMware, but Microsoft licenses some of their things. But in my past, what we would try to do is we try to group Microsoft VMs all on the same host so we wouldn't have to pay for licenses on different compute nodes. So having something like this, that could be one area of value for you. But also this could be if you have customers that want to place all their VMs on certain machines. But the neat thing here with scheduler is you could actually write your own filters. So if you're talking to different third-party devices, different load balancers, I think you can get really creative and you can write your own filters and schedules here. Yep.
Which scheduler is this? Because I lost track of things places ago. So I'm scheduler,
well, there's different schedulers that you can use or different filters you can use within Nova Scheduler.
Okay.
So these are just the different filters.
These are all implemented in Python?
Yes. Yep. So, and honestly,
This isn't just one filter scheduler, it's actually...
these are different filters. Yeah, so you have one scheduler and then he's talking to different filters. So,
Can you control the order of the filters?
That I would have to get back to you on. I don't know if Darren's in here.
I'm over here.
Do you know if you can control the ordering of the filters? Like which one gets read first or anything like that? I don't know, but we can. If you give me a card, I can get you the answer. But again, I think if you sit here and think about it for a second, this is where you can add a lot of value for your business by writing your own filters. And I think we've seen in different environments where people want to have gold, silver, platinum offering and things like that. And so these filters can do that. You can say this compute node has this level of hardware. Let's place instances here. And then have you guys written any custom filters for your guys' deployments?
No, we cheated and did it the backwards way. We live migrate stuff onto where we want it to be.
Okay, so
Follow-up question on that. Based on what you were just saying there, if we had an environment, because I know you can do multiple hypervisors underneath, we had KVM on some and VMware on others, and obviously VMware, with the cost comes with a higher service level. Could you run both KVMs within the same OpenStack environment and then possibly use filters to say certain clients end up with VMware hypervisors? Versus
yes,
KVM?
absolutely. You could absolutely do that. Now, just be careful. If you want to migrate between the two, you're not going to be able to migrate. But yeah, if you want to schedule that, absolutely. So, I've met with different customers, and I said earlier, OpenStack isn't or, it's an and thing. So if you use KVM and VMware, what I would be doing from a service provider perspective, I'd say, oh, you do want VMware? Okay, well that's going to cost you an extra money per hour or whatever you want to charge for.
I'll EC2
Yes.
vertical versus
So,
Can you schedule groups of servers here?
well, you can list different. Well, no. So if you want to list the servers within that filter that you can actually deploy to, you can build that. But with an availability zone is just going to be an area.
Is it still one at a time?
Sorry,
Is it still one at a time?
what do you mean?
One VM at a time?
Provisioning?
The
Oh no, you can
scheduler-
provision multiple VMs at a time. Yeah, yeah.
But the scheduler evaluates filters one VM at a time, right? Or does it actually?
Oh, you're saying do it in parallel?
Yeah, I don't, if you're doing, is that what you're
You
asking?
can't do
If
like,
you're doing like
you can't do
20
like a cluster compute
instances.
instance deploy where you create it.
Put all these VMs.
But-
Oh, no,
Yeah.
it's probably gonna go by every single one and look it up, and then it's going to decide where to place it, or which, yeah.
Oh, I see what you're saying. So it's pitting a request against each other to say, I want them all. in the
Yeah,
same
you wanna,
network or something.
yeah, there were a couple of blueprints a while back that were trying to do sort of a, airline deployment thing where you would say, I want 10 servers and I want them all be within 3 hops of each other.
Yeah.
Or 1 hop of each other, and you come up with a plan, you lock the spaces, and then you go, and then you deploy it.
Oh, I see what you're saying. Just
Can a
make it,
filter use the current state of the environment to trigger a filter?
yeah, so you can, I mean, you can look in Ceilometer and you can pull different things, and you can have filter look at things, and like get the
But
state of the
could it
environment.
also look at the state of Nova and say, well, this VM that I care about is already over here, so I'm going to go over here?
Yeah, well, that's some of the same host filter.
Oh, I guess, okay.
Yeah. But I mean, you can key off a lot of different things. So look at this. I mean, research this piece, because I think there's a lot of value, a lot of customizations that you can make here. And if there's any managers or executives here, I think this is where it gets kind of interesting, because this is where you can get into like policy-driven decisions.
One thing Morantis have, making good policy decisions is one factor, but like typically as an engineer, my preference is just to make
We won't make any recommendations. We're not going to say this is how, yeah. We'll be
I'm sorry for that.
Yeah, we'll be neutral to it, so we'll work with you. And so I was telling some, I mean, we talk to our customers and try to figure out what they want, and then if we need to write a filter or something, we'll do that.
I guess I just made them like, scheduling is a decision for like where to get stuff. That's ideally you can evaluate that.
Yeah, this isn't something.
This tells you where you're going to set up. Set up there.
This is an OpenStack. This isn't a Morantis or that. So anyone. All right. So now we have the provisioning. It's gone through scheduler, and now we're going to pick the actual host ID to actually do the provisioning. The actual compute node says, all right, I'm ready. I'm going to kick off the provisioning. So now let's look at what Nova looks like. So the Nova Compute project, we said here you basically have your hypervisor agnostic, and even eventually, well, I think they've already pulled it out, but originally used to have the bare metal still in here, but this may get moved directly out because it's going to be part of the line. But you have your Zen API, so you can talk to your Zen servers, your Citrix Zen servers, libvirt, so you have KVM in your Linux containers. And then from the actual other compute drivers, and these are things that people have contributed. So Power VM, I think Power VM has actually been deprecated. I believe. I think now they're looking at like Power KVM because I think Power VC is what we're looking at. But so obviously Docker's there in Hyper-V, and then VMware is now there. So someone asked me earlier if I have an existing VMware environment and I have all my VMs provisioned and I want to load OpenStack on top. What will happen? OpenStack actually will not go out and discover. Basically, you'll have to lay it on top, and then you can provision new VMs, and they'll be sitting within the same cluster. But then you'd have to kind of manually migrate your application between them. Yes.
If they changed that, the last time I read the documentation, it said that Cinder provides basically all of the resources to OpenStack, and so you have the potential to step on your VMware infrastructure. And so, like, even if you went through the trouble of creating all of your VMs, which you can provision VMware, not only would it have to be specifically written for VMware build, but then when you go to deploy them, OpenStack is where any competitor has to do it. So if you had that cluster, say, had 100 VMs in it,
Yeah.
because
That's absolutely correct.
Yeah. So nothing changed.
Nothing's changed. Yeah. And
That's why we didn't do it. That was exactly my plan. I was literally like typing while reading documentation, and it was like, oh, full stop.
yeah. So that is again, I'll call it not an OpenStack. It's just it's not a knock, it's just the community hasn't built that, or VMware hasn't contributed that ability. And really, to do that, I mean, so that's just doing the discovery of the VMware environment and translating that into.
Well, I would say that's OpenStack. I would say that's OpenStack lacking, because I mean, even if you go by, you know, like an IBM functionality, the switches that they have know how to talk to VMware and find out where all the VMs are, and not only that, but they can also figure all the policies and migrate across.
Sure.
So it's there.
Yeah, and
We're just not doing it.
yeah, OpenStack could. I mean, OpenStack could add this in. You know, I think, you know, from our standpoint, I'm saying OpenStack is an and thing, but there are a lot of people in the community that are saying, hey, let's move away from VMware, and we don't care. I mean, we just want you to have your application however you want. But you're absolutely right. I think the challenge is if the majority of the community says, well, we don't really focus on VMware too much, and we really don't see it that much, then they won't fix it. You know, they won't add that back in. And
Well, I think VMware should.
I agree.
Because they're the ones that care about buying their servers.
I agree. Yeah. Yeah.
It's really, right now, it'll only be either, I think that they're really interested in support or not. Assume that like if you want to actually use it, you know, just like you have to use Cinder or MSX.
Well, yeah. So if they add it, if they put it upstream, then you know everybody in the community will get access to it, and then it'll be fixed.
Yeah, I mean, they just released the new game, right?
Right.
And it's not, I mean, I read it and I was excited for it. And I found myself a lot of times just kind of reading, going, why would I want to do this?
Well, I'll say this in their defense, not defending them, but if you have a whole bunch of VM clusters already, then, you know, it's very painful to put in this stack. So it makes sense to them to make it easier for you to move away from it.
Yeah. Yeah. A lot of our customers that are using VMware today is going to be greenfield. And they know, and what their thought is that, I mean, depending on our enterprise customers I speak with, a lot of them have gotten really good deals on VMware already. Some of them are really good at twisting their arm, getting good licensing deals. But a lot of customers don't have that influence, and they pay really high licensing costs. So them using OpenStack is a way to get off of OpenStack. So yeah, I think VMware probably doesn't really want to give you that ability to make it easy. They want you to stay sticky. But I agree, I think that would be great to have that capability. Okay, so now we provisioned it, and then now what's going to happen is that it's actually going to go through Conductor. And I said, sorry, it's going to go through Conductor. And I said Conductor is kind of a security mechanism for Nova. And so Conductor itself, this is so you don't actually get direct database access. So from a security perspective, you're actually using Conductor, and Conductor is the one that has the direct connectivity to the database.
Obscure, which enterprises may be involved. Is there a security issue around that now?
No, I think it's just the fact that if you're able to, if an API is able to hit the database directly, then there could be, I guess, security vulnerabilities or other potential issues.
There's a lot of trail.
I mean, you can see in the logs when people are issuing provisioning tasks. I mean, you can see that, but like if I'm hitting different APIs, I can see, typically in the logs, like who's hitting what API. So I mean, you can look to see what's going on, but again, I mean, the concept here was really security focused. All right, so now we've actually provisioned, and yep.
I was going to say, does Trove do that type of thing, and if so, why didn't they go through Trove? Why didn't they have?
Trove is a newer project, and I don't know if Trove has something similar to that.
You would still need the database.
Sorry?
You would still need the database.
They're set, so what Trove is just database as a service. So I could have my MySQL, or later it'll be other more databases. And so the idea is that OpenStack can orchestrate provisioning different databases for you. So whether you're going to do like OpenStack on Trove, like dogfooding, OpenStack dogfooding itself, I don't know if we'll get to that point, but what's that? It already is using Nova, and it's putting the different components. No, but what I'm saying is the actual pieces.
So there was a talk about that. I think even now.
Yeah. So for example, like with Nova here, this Nova database, I'm not going to use Trove to provision this database, at least right now. So maybe in the future, they will actually say, okay, we're going to use Trove, we're going to say provision this database, but that's not happening today. All right, so the next thing is, we've got our VM provision, and now what about the networking connectivity? So now we're going to hit the Neutron API. And so in Neutron, this is, I mentioned earlier, this was originally the Quantum project. We're still issuing different API calls. You can create your different networks. You can associate your VMs to those different networks. You can create your routers. You can focus. You can play with your different security groups. So here's your API. So now when we look at Neutron itself, within the community. So again, I was at OpenStack Silicon Valley yesterday, and there is some partner around Neutron specifically. And you said you had 200 nodes. How's your Neutron been experience? Okay. How's Neutron been? Or what issues have you guys run into? Or if any?
Well, we use
Okay. Okay. How come you don't rely on Neutron? So Neutron has several areas that we need to look at fixing. And the biggest one that we see from our customers is that the actual Neutron, the router right now, is a distributed virtual router. And so within Juno itself, you're actually going to have DVRs, not like cable box, but a distributed virtual router running on each compute instance that's going to handle your layer 3 traffic. Today, that's actually just running on a single node, which we talked about scaling everything out horizontally. It's like, oh, but we forgot that. So yes.
How does that compare against using commercial solutions like NSX?
Yeah, so I can't speak to NSX because I personally haven't used NSX. I don't know if Darren's here and can speak to that. But so, for example, PlumGrid is a vendor that I've worked with, and these other vendors have looked at, they fixed it, in their own different ways. So, PlumGrid, as an example, they have IO visors, and they will install that module back in. But the challenge for these guys is that the open source community will eventually catch up and will start mitigating some of their advanced capabilities. But NSX should be able to handle that no problem. It's
but is DVR intended to supplant things like NSX?
All it is just to supplant the actual router. So now you have a horizontal scaled out routing infrastructure.
But it doesn't handle things like VPCs or anything like that.
What's your end goal? What are you trying to?
It would support the equivalent of VPCs and effectively SDN.
So I mean, you can still create different networks. You can still create different private networks. And today within Neutron, you can create GRE. You can create a GRE mesh. So your layer 2 boundary is going to be connected to all different nodes. You have different tunnels. So you can set that up. But so I can create my different VMs, and I can say these VMs are only allowed to speak to this network, and that network is going to be across a mesh of all my nodes. So depending on what you're trying to do, like today with the Neutron you can do that, but the biggest challenge is the routing differential.
And DVR is supposed to
hit in Juno, which is in November. So that's the biggest complaint everybody has right now with Juno, with OpenStack, or with Neutron, because we don't have that distributed virtual routing capability today.
So what happens with the vendors that, because right now the way the network is, I can do a plugin. That's the only person that can plug in. So if you want to do NSX, that's great. If you want to do Cisco, that's great also. You can do both. So
Yeah.
is there any solution company for that?
Yeah, because with module layer 2 plugins, you should be able to run multiple already today, but
I mean, like if you decide that you want, whoever, that's who you're going to.
yeah. Yeah, because ML2, and we'll talk about that. I mean, you'll be able to pick different vendors that you want to talk to, but I mean, I can dig in and get you. I mean, I haven't touched the configs to actually see it, but I can dig into that. Okay, so now we're doing the Neutron piece, so we're going to be talking to all of the local switches, the OVS switches, and so I have the different side of the top, so OVS, but OVS is actually, OpenV switch is actually a very complex piece of the infrastructure, because that's where you're going to be setting up your different flow tables, you're going to be setting up your security groups. You're going to be setting up all the different meshes for your tunnels. So a lot is actually happening within OpenStack Switch. Okay, so now we have the network connectivity has been made. Now we need to talk to our DHCP and our IP management information, and then also what about the router and the networking piece. So moving through Neutron, and we can blast through that pretty quickly, we can keep going deeper, but now we already have the network set up, we have the actual VM itself set up. Now what about our storage? So storage can either be local disk, or it could be a remote block device. So this is now where we're going to be hitting the Cinder API. So the different concepts here is you have ephemeral storage, and this is basically once you shut down the VM, the storage is gone, and this is a typical cloud model. So if you basically want to have it persist, you can basically create these different volumes with block devices. So these block devices can be running in Ceph, they can be on LVM. Challenge if you're running on LVM, if you lose your actual node that has LVM installed, that storage is down. So not a good idea. So typically you're going to be using something like Ceph. You're going to be using some third-party storage device. It could be exempt EMC, pick your vendor. As long as they have a driver, you can connect that right in. And then from an object storage perspective, object can either be Swift, Cinder. I think React is even in there. But this is where you can actually keep your files and your VM images. From a block perspective, it's really interesting when you do this. And you can do a quick Google search and you can look at Cinder drivers or Cinder plugins. And there's a whole list of all different vendors that have contributed drivers. It's really cool to see it in action when you actually say Cinder create a volume. It'll actually go out to that device, create a LUN, and then when you actually attach it to the VM, it handles all that automatically. And if you were to write that code yourself, I mean, there's a lot of things happening, which is kind of cool. So, question?
No, picture.
Oh, okay. So volumes, these are read-write block devices. The one piece here, which I'm confused, and I don't know why the community hasn't done this yet, is why the actual volume can only hit one instance at a time. That doesn't really make sense because if I want to run a clustered file system or something like that, I should be able to do that virtually. Today, to my knowledge, I believe we actually contributed code that you can do it read-only, but not read-write. But again, if I want to have multiple volumes on multiple nodes, the same volume on multiple nodes, I should be able to do that, but that capability doesn't exist today. Snapshots are in there as well, and then backups if you want to create an archive of that volume. So the Cinder architecture, we kind of talked about this. All the projects have this similar design concept where you have your actual API, you have your scheduler, you have the queues, and then you have your database that's used for state. And then you actually have your different volumes and different block devices. So another question on this is, in my Cinder instances, kind of to your networking question, can I support multiple Cinder devices? And the answer is yes. So you can configure multi-backend. The negative thing is that a customer of mine just had this issue where they said, hey, we have this new HP SAN, and we're also using local disk, but when we do a provisioning test, can we provision and put the OS directly on can we pick what volume type we want to use? Today within OpenStack, you can't pick the volume type to use on provisioning. So there's only a way within Cinder to say default volume type. And the default volume type, you have to be very specific. So that's a known thing. The community can fix it, and I think we should.
You mean in terms of IOPS and things like that?
So, for example, let's say I had local disks, so I have LVM. Say I have EMC, and let's say I had a flash array like Pure. And I say, well, this VM I want to provision its base image on Pure. I couldn't do that through provisioning. What I could do is I could say, what's that?
In one step.
In one step. Well, what I could do is I could say, provision this VM, and then attach block storage, but it's going to be a separate device. I can't tell it like /dev/SDA is going to be on Pure or it's going to be on EMC. It will only use the default volume type that I define.
Oh, so you can't have different groups. Go ahead.
Can you still create the volume first?
I've tried that, and looking at the community has blueprints specifically. If you look, you say Nova choose volume type or something. You'll see people trying to do that, and it won't allow you to do it. So
And that's just limiting the boot device?
it's just the
or-
boot device.
Okay.
Yeah, so on attach, so you can say, you know, create boot image and create volume. It'll just pick the default, and then you can still attach other volumes, so it'll show up as like /dev/std. So I said here, you can Google the list, but here's the list of some of the different vendors that have contributed drivers. From a fiber channel perspective, the actual array I was working on was a fiber channel array, and a lot of people using OpenStack don't use fiber channel, it's usually iSCSI. But it worked well, and really no issues. So a lot of companies are still contributing new drivers. You can actually look at Cinder blueprints if people are still contributing. So backup drivers, again, so you get backup integration with Swift and Ceph and TSM. Okay, so now we've gone ahead and we've said provision that volume, and now we say use that volume as the new block device. Nova Compute said request the VM image from glance. So what kind of image am I going to use? You know, is it going to be Linux? Is it going to be Windows? What's the image? Go to glance. So that could be Swift or whatever you want. It's going to go there. Now this is your actual yes.
Yeah, there we go. So I guess my question is this what you would consider a base OpenStack install? Like, because I don't see a number of things on there, like numbers or heat or any of that stuff. So is this, if I was going to implement the 101 just to play with OpenStack, is this what I'm implementing?
So I can tell you is if you were, I'm not trying to spread propaganda. If you're going to download Ranks OpenStack, you can enable heat, by default. And I can't speak to other distributions if they're actually including that. But the default, most default should give you Nova, Neutron, Cinder. Whether heat is included or not, that's going to be up to them. But
when you go to OpenStack, when you go to OpenStack website, they have like
okay.
And they have like dev stack, and they have, this is how you do it if you have 3 boxes, stuff like that. Is this what you're setting up when you do that, or are you saying?
This should all be set up automatically, out of the box if you're using some sort of dev stack or something. It should build all these pieces.
And so the other option would be to download Ranks or something like that and set all this up. But if you don't want to,
and when I say set up
one, so you want to set it up yourself and kind of learn it. This is what you.
Yes, you're going to have to set up all these different components.
Right. Well, so if you the install, like, so you can do Ranks, you can do RDO for that. There's a thing about dev stack. And it does everything for you, and it's completely accurate. It's awesome. I mean, they're all awesome. Like, you hit go, and then you.
Right. Yeah, but if you want,
you have no idea what happened underneath it.
Yeah.
And I think I was talking about this in the last one. Eventually, you get to the point where you're like, well, what's really going on? So if you read the actual guide, it'll walk you through it. So you set up, you set up the database, and you set up some of the messaging and stuff. And if you look at Juno, which is still being written, they actually use RabbitMQ instead of the local, whatever the local login is, that message system is. And then you would set up Keystone, and then you set up Nova, and then after you set up Nova, you do Neutron, and then, or Cinder, and you do Neutron, and then the next step, and at that point done. And then at that step, they tell you to do Horizon, and then whatever else.
So I want to just throw out a word of caution on this. A lot of you don't talk about this kind. It is really for development. I've seen many people spin on dev stack, and I set up all my instances and all my work machines, and then I did something that everything went away. It's like, yes, it's set the dev stack. It gives you a clean slate every single time you start it. So it doesn't stay around. So if you just want to spin it up and play with it, install the Red Hat under Rantis, or go with one of those. But be careful about that stack. You just play with it as a user. I wouldn't recommend using that stack. That's just the first really problem you use.
OpenStack docs are really good. I have many problems with Python stuff.
Yeah, so you could build it on your own. I actually had a previous coworker that did it. The way I look at it is I just remember using Linux back in the day, And I mean, there are still distributions where you can compile everything yourself. But I was never one of those guys. I was like, I want to compile everything. I just want it to work, and I want to get started. So I mean, but from the learning perspective, absolutely. I mean, get in there and figure it, and you're probably going to learn a lot.
In our class, you actually go through the installation component. You're not installing Ransom, like you're installing OpenStack. You installation component, install Python, you install database, you configure every component manually in the class.
I got a question for you on the using block storage and using Lansing API. Is there a way to cache that somehow? What we see is a lot of traffic from like when we're using block storage. You know, like if you use like Node 2, you can cache the image for it, but with block, it always has to go out and grab it from Lansing. So if you have larger images, then you have a huge amount of train.
Yeah. I don't have an answer off the top of my head for you, but I mean, I can get back to you on that.
Okay.
Okay. So we're grabbing the image. So we plans again. This is retrieving the different images. And then I mentioned earlier that you can use multiple image backends with different images. And, so Swift, you can use your file system. I mean, lots of different options there for where you actually want to store your images. But yeah, I think I can definitely ask. Logically, there should be a way to do that. Okay. Okay, so now we're grabbing the image. It's going to copy it. And now Node Compute is going to get it, download it. So at this point, what we should have done is that we basically established all the different pieces. We configured, we've made the call to Nova, we've gone to Keystone, we've created our volume, we've created our different networks, we've got our IP addresses, we've grabbed our image. So now what we actually should be able to do is we should actually start provisioning. So now it's going to update the state within the database, and then now we're going to say, what's the status? What's the status of this VM? When we're successful, was there an error? So again, just to recap everything that we just did, so we walked through Verizon, we went to Keystone, we looked for the scheduler, we looked for the different filters to find the correct host, we went to Cinder to create a block device, we grabbed the image through glance, we pulled it down, and then we actually instantiated that VM on the hypervisor. So, developers win. We talked about this earlier. A lot of developers here. You guys asked some really good questions. I'm sorry I didn't have all the answers. But yes?
So the Amazon does all this stuff in the background. You know how Amazon does it? They have the same type of service.
Amazon has probably the most advanced services.
We know how to deal with this behind the curtain.
Well, yeah, I mean, they're not going to tell you how to do it. I'm sure maybe some of us have friends and everything that will share some tips, but
Amazon either has the most advanced services or the most
yeah. Yeah.
AWS.
Another question, you have load balancers too?
Yes, there are. So load balancer as a service can be enabled right now. And so you can be using something like HA proxy. And in the future with the ML2 plugin, I believe you'll be able to hook up different third-party load balancers as well.
So that's really cool.
Yep.
Is Keystone for authorization and authentication?
Yes.
So it's equivalent to AWS's IAM.
So the IAM is which people? Sorry.
Access management.
Yeah. So it's tracking all the access is controlled through Keystone.
So you can restrict, for example, access to specific instances to specific users.
Yes. Yep. Lastly, here's some sales stuff for you guys. So if you guys want to go to the class, it's not a Marantis propaganda class. It's an OpenStack class. As Darren mentioned, if you're going to be installing OpenStack from scratch, there's a lot of value there. So you can use this discount code, go to our class. These actually fill up really fast. So if you guys are interested, get in there. But that's it. Yep.
Hey, we had the probe question. So, I checked. MySQL and Cinder, and then Oracle is looking at probe for their 12C product because the 12C product is multi-tenancy. So you'll be able to make requests to Trove to actually launch databases in Oracle 12C. So that's what Oracle is looking at Trove at.
Yes.
Okay. So you can ask questions.
actually get the VM. Now,
It will start hand.
I mean, yeah, I might actually I've got personalized that VM. Integrated with like Active Directory, let's say.
Yeah.
What's the path? So, okay, so now what we've got is a whole bunch of, I can spin up 1,000 VMs quickly, but I can't actually connect it with an Active Directory or personalize that VM to actually be used for specific purposes.
Yeah, so Windows gets a little tricky because with Windows you basically have to create like a new SID and stuff like that. So you can basically create your templates of your image for your VMs. I think we're done, so you guys.
If you're done, I'll hold your chair.